Hi folks, Chuck Black here, 52 weeks of Python. We are in week number 18. The topic this week is tuples. In this session, you might want to pay attention even if you're not all that interested in tuples, because not only will I be introducing you to and talking about tuples, I will also be talking about things that are quite important, such as mutability, immutability, something that is new that I haven't talked about before, which is the idea of hashable. And lastly, I give examples of how not to write code and how to write better, cleaner code. So hopefully this will be useful to you. So without further ado, on to the lesson. Enjoy. Okay, so let's get started talking about tuples. Now, as a change for what we normally do, what I'm going to start with is going into Python and showing you little simple, trivial examples of what a tuple is, what it can do, what it can't do, etc., just so that it's very simple. And then I'm going to move into some more real-world situations. So here I am. Let's run Python right here. So now we're within Python, and I'm going to say L equals square brackets because I'm creating a list. 1, 2, 3, close brackets. And now if I just type in L, it's going to print it for me. And it's printing that it's 1, 2, 3. Now, if I want to make a tuple, then one thing that I could do is I could say T equals, and I use round brackets, 1, 2, 3, 4. So let's just do that. Now, round brackets are going to make it into a tuple. So if I just print it, you can see it's printing it 1, 2, 3, 4. Now, let's pause for a second. A list and a tuple can be iterated very easily. So, you basically have a sequence of things in whatever order you put them in, and you can go through them one at a time. In this situation, if I was doing a for loop and I was looping through L, I would do the 1 the first time, 2, and then 3. The same thing would be true for this tuple here. So this is a tuple, and these round brackets, or parentheses as we would call them, are the way that we can help to identify, when we're listing data anyway, what a tuple looks like. I know we've used round brackets before, specifically when we were doing compressions, and in that situation we were doing generator compression. In this situation, though, this is just displaying data, and so this is showing us that it is indeed a tuple. Now, what is the difference between a list and a tuple? Well, I'm going to say L, if I can spell it correctly, L.append, and I'm going to append the number 9 to that list. And now if I print L, you can see I now have 1, 2, 3, 9. Now let's suppose I wanted to do the same thing to my tuple. I say T.append 9, so I just want to append 9 at the end of it. And you notice it's giving us this really user-friendly error. Python is great in many ways. User-friendliness, not always the best. You have to sort of parse through everything, the traceback that it gives you. It's just telling me where in the program it failed. But here's the real important thing: attribute error. Tuple object has no attribute append. So that's telling me I can't do an append. Well, so how am I going to actually append something to a tuple? And the answer is you don't append things to tuple, and you don't do extend, which is what you do when you put two lists together. You can't do that either, because tuples are immutable. Remember our discussion of everything is an object, and we talked about the terms mutable versus immutable. And immutable means it can never be changed. A tuple can never be changed. So once I created T like this, I can never change this particular object that T points to. It is fixed. Now, if I wanted to instead say T equals, now I'm going to be assigning something entirely new to it. 1, 2, 3, 4, 9. Just for kicks, let's have it be the same. Of course, I can do that. So remember, when we say it's immutable, that means this object that T points to can never change. I can always reassign t to something differently. And that's what I did here. Let me pause for a second and make sure that that sits in. At this point in time, I'm saying, I want you to take the variable name t and point it at this object. So it's creating this object. It doesn't matter that before I said t was equal this object. In fact, it doesn't matter the data type at all. This is one of the things that I could do. In fact, I don't know if I've done this before, but I could say t equals Fred. Poor Fred, I always pick on Fred if I wanted to print it. There. Now what is it? What data type is it? It's a string. So yeah, you get the general idea of what it is. So I'm going to go back and just have t equal this. So here we have our tuple. So let's say we've been given a list, like in our situation, what's L equal to? We've been given a list, but we want to deal with it as a tuple. Let's pause. Let's ignore for the moment why I would want to do this. How can I get a tuple out of my list? Well, it's very easy. I'm going to use t again because we keep using that. I'm going to say t equals tuple. I'm going to use this built-in function of L. So at this point in time, what I'm saying, let's look at this. I'm saying I want you to call this built-in function called tuple. This is how I am telling Python, I want you to take the thing that I'm passing you and turn it into a tuple. And now let's look at t. T is what L was. Remember, L was 1, 2, 3, 9. Now t is also 1, 2, 3, 9, but look, it has the round brackets instead of having the square brackets, and that means that it's a tuple. So that is fundamentally all that a tuple is. It is a list that can never be changed. You can iterate through a tuple in the same way that you can iterate through a list. You reference items in the tuple the same way that you do in a list. And I'm going to pause here and ask you this question. I'm going to say t sub 1 and ask Python to print that out. I want you to pause this unless you know the answer already, and I want you to tell me what value is it going to print. So giving you a second to think about it. The value that it's going to print, t sub 1, is actually 2. Why is that? Because this one is t sub 0. Everything in Python, and I don't know that I've gone over this, maybe I should have gone over this more, but things in Python are what we call zero indexed, which means it starts at 0. So t sub 0 is this one right here, t sub 1 is that one right there. And I probably, now that I'm thinking about the classes that we've done, we haven't referenced items that much like this. I know that I have, maybe I have or haven't explained them enough, but this is basically, it's like a subscript in older languages. It's how you specify what item from T I want. In this situation, remember, I did L. I have L. Now L, the actual values of L. In fact, let me just do this. Let's remind ourselves, what is L? L is a list that's 1, 2, 3, 9. And what is T? T is a tuple. That's 1, 2, 3, 9. So it has both of these. Now, these are entirely different objects in Python, so they're kept separately. They behave differently, so you need to remember that. But if I was to say L sub 0, we see that the data that they're referencing is actually the same. L sub 0 is going to be 1. T sub 0, whoops, not T sub O, T sub 0 is also going to be 1. So the point I'm making is not that these are the same data. They're not. They're entirely different data, and I'll show you that in a minute. But the point is that you dereference them. We call this dereferencing an item within a list, in this situation, in a tuple. When we both look at the first one, we do it exactly the same way. And for those of you that know a little bit, I'm going to say ID of L, and it's going to give me a value, and I'm going to say ID of T, just so that you know that these are indeed entirely different values. It starts to go different towards the end. There's L, and there's where our tuple points to. And that's kind of the general idea. Now, let me give you a little bit of information about why you would use a tuple. Now, one reason that you need to know about tuples is because people may be using them in code that you need to take over and amend or maintain or whatever. Also, some Python packages that you use will return data in the form of tuples. So you'll see something that looks like this, and you'd say, well, I'm kind of used to dealing with lists. What's this? And the reason that they're doing this is they just return data in the form of a tuple. And if you then want to actually do something to it, like let's say I have this T and I want to do something to it, then what I could say is I would say like L1 equals list of T. And now here's L1, which is initially going to be the same value. And now L1 dot append. And this is going to look weird. I'm going to use my name this time. And let me pause after we do this. There's L. There's L1, which I just made the change to. So let's stop for a second because I want to talk about this. And this is not necessarily tuple related. The thing that I'm pointing out is that by simply taking this object, creating a list using the data from that object and calling it L1, I can now do an append. So if you are given a tuple, it's very trivial for you to convert it into a list. You're not really converting it into a list. You're creating a new variable which actually is using the data from the tuple in order to populate the list, and then you can append stuff. I do want to point something out here. For those of you that may have used C, you may be shaking your head and slapping yourself on the side of the head, as I do quite often. It's not always my wife that's slapping me on the side of the head. Sometimes I even do it to myself. And if I was a programmer with languages such as C, or even languages before that, I would be saying, wait a minute, what are you doing here? You can't do that. This list actually is containing different data types. This is clearly an integer, and bam, a string. What's going on? First of all, can you do that? Is it legal to do that? And would you ever want to do that? Well, in answer to the questions, let's see if I can remember the questions. Can you do that? Yes. Is it legal? Yes. Why would you want to do that? Is that my third question? I can't even remember. There may be reasons why you want to do it. The data types may be different. Some people, I've seen just this morning looking this up, have commented that tuples are a little bit more like C structures than lists are, but in fact, both of them can contain any type of data that you want. So you could have an integer followed by a Boolean, followed by a string, followed by a class, followed by another data structure like a dictionary. You can have whatever you want in there, and Python doesn't care. Can you still iterate through it? Absolutely, you can iterate through it. Would it make any sense to iterate through this? Probably not. So if you have disparate or different data types, you probably don't want to iterate through it. But I kind of got myself off on a tangent there, but I just did want to point that out. And can I now turn this into a tuple? Well, let's say T1 equals tuple of L1. I think that's right. Now let's print out T1. So we see that it's exactly the same data, except it's a tuple form. Now I cannot change it. I can't do a little append like that. I would have to create an entirely new tuple in order to do that, because tuples are what? They are immutable. That means they can never change. Okay, that's our quick little introduction. Now I'm going to talk a little bit more about why we would actually use a tuple. All right, so let's look at tuples in the context of a more real-world situation, or at least real-world in the context of what we've been talking about with lists of devices, and those devices are dictionaries, etc. etc. You'll remember that we created this thing called create devices, and if I dive down into it, you'll remember that it creates a list and then appends things to a list and returns that list of devices. And you may have been thinking, oh, Chuck was saying that sometimes these packages and functions that you call return tuples instead of lists. So maybe instead of calling create devices to return to me a list of devices, I could be returning a tuple of devices. And how would I go about doing that? Now, what I'm going to describe to you is, and show you and demonstrate to you, is me doing it in a stupid way. Now, you may be saying to yourself, Chuck, how is that any different than the way you normally do it? We kind of think that the things that you're doing are a little bit stupid. If we're completely honest, then I would say yes, but the difference is that I am going to intentionally do something stupid, and I want you to just bear with me and see what I do. And what I'm hoping is that I will be demonstrating to you, okay, well, here's a way that would work, but probably not the best idea. So let's do this. Let me start by creating another one of these. I'm just going to copy this line. Now, normally, I just want to save myself from typing, and I'm going to say, what if I say create devices tuple? And so I'm going to go ahead and create a function called create devices tuple and have it return to me a tuple. Now you can see that this went gray because I'm not using that anymore. I'm going to say I'm going to create this thing, create devices tuple, and now this is happy because it believes that it exists, but this isn't happy, and this is in PyCharm. It's actually looking into util.createutils, and it says, wait a minute, you don't have a create devices tuple in there because it's actually looked and examined this file and it doesn't see one called create devices tuple. So my next thing that I'm going to do, remember I'm being stupid here, and again, that's not a stretch for you guys to think that, but I'm going to go down into create utils and I'm going to say, oh, I know how to do create devices tuple. I'm going to just copy and paste this entire function and then make changes. Now, in general, before you say, of course, that's a stupid thing to do, I actually do this a fair number of times because I want to have a knowledge of what I have done before when I go through and change it. But this is more of a minor copy and paste violation of correct coding practices. So let me show you here. So this is what I'm going to do. I copied it. I'm going to paste it. Now I'm going to say create device. Oh, by the way, you notice that it's highlighting that. If I was to do that, it's telling me, PyCharm is telling me, oh, I redeclared create devices. Oops, that would be a bad thing. But the good news is I'm actually going to rename this, right? I'm renaming this underscore tuple. Create devices tuple. Is that what I called it? Create devices tuple. And now you can see the PyCharm has looked ahead and it says, aha, there is something called create devices tuple. And in fact, if I were to run this right now, what would happen? Well, it would work. It would work perfectly well because create devices tuple is exactly the same as create devices. If you don't believe me, let's go ahead and run this and I'll see if I believe myself. Okay, so it did run. And I printed out devices that I got back from create devices tuple. But now you're saying, Chuck, you've outdone yourself. You're even stupider than we thought. We're well aware that you have not actually changed it yet. And so it's doing exactly the same thing. Yep, that's entirely true. Create devices tuple, and you can see it creates a list. And then it goes through and it returns it. So if we wanted to begin working on this, remember, I'm going to show you mistakes that you can make. You might say, and this might be a legitimate thing for somebody starting, well, instead of creating a list, why don't I create a tuple? So I'm going to say create devices and have it do create this tuple. So create devices is now a tuple. Now I'm going to go through here and I'm going to go through and for my created devices, I'm just going to continue to create my tuple by doing a dot append. And I actually haven't run this, but you're looking at this and you're probably way smarter than me and saying, wait a minute, number one, you can't do that And number two, you're a little bit appalled that PyCharm didn't find that. Well, there are certain things that PyCharm can find and certain things that it can't. If you are on the ball, then you're probably saying, okay, create devices, that's a tuple. We just went through this. You cannot do an append on a tuple. Let's run it and see what happens. I actually haven't done this. Like I said, up here I get my nice, super helpful, easy to read message. As you can see, it's telling me this information. This is where I called it from, create devices tuple. This is the line that was offending the Python. And again, this is the same error that we saw before, right? That tuple has no attribute append. So now you say to yourself, okay, well, you've thwarted me so far. I can't do that. I can't return this as a tuple. What if I just undo this? So I'm going to, whoops, it didn't undo it, did it? There we go. I'm going to undo this and let it be a list. And then I'm going to do something sneaky because I know that Chuck told us that we could just call tuple on something and then I can return a tuple. So I'm going to come down here and I'm going to learn how to type first. And I'm going to say tuple parentheses created devices. So what's happening here? The first thing I do here, I create the list. I go through the list. I create it. And when it's all done going through here, what am I doing? I am going to return not created devices, which is a list, but I'm going to return a tuple that was created with the data from created devices. Okay, do you see what I'm doing there? So I'm returning a tuple. And now let's actually run this and let's see what happens. Now I'm running it and unfortunately, fortunately it worked. That's a good thing. I'm not saying unfortunate about that. Unfortunately, I don't have the first version available to me, but I'm going to actually go back and look at it. What do you notice is different in this from what we saw on the first one? Now you could stop and go back and see the one that I did before, or you could trust me and believe that I will show this to you again. I'm going to go undo the tuple that you see over here on the left. What do you notice that's different? There's only one thing that's different. Well, technically two things that are different. This whole thing that it printed out is surrounded by what type of bracket? Round bracket or parentheses, not the square ones like before. And notice that doing the thing over here in tuples, when I did a pretty print, it's basically going to iterate through the thing that I have here. Pretty print, it's actually perfectly fine printing things out exactly the way that it was before. So it's inside pretty print, inside pprint, it's actually doing the iteration and everything works perfectly well. So let me keep this in your mind right here with the round brackets. Now I'm going to come back here and I'm going to undo this. Undo my typo as well. Now I'm just going to return the list and let's see what happens when I run it. So what did you notice is different? Do you notice this? You would be able to notice it if I get the cursor out of the way. Square brackets, that means it's list. So these things are fundamentally the same, but I am, instead of doing returning a list, I'm returning a tuple. So let me finish this so that it looks correct. I'll run it one more time. Remember these square brackets. And if I've typed that correctly and I run this, it's exactly the same except it has round brackets. Now, the round brackets, it's not just a bracket. It means that you cannot change this. So I would not be able in here when I get returned this devices, I would not be able to make any modifications to that. I could reassign devices to a new tuple or to a list or to a string or to whatever I wanted to do, but I cannot actually change that object because it is immutable. Now let's talk about whether what I did was a good idea. Let's say I come in here and I figure out a better way to do some of the stuff that I'm doing. Maybe I want to change, actually let's go back here, created devices, which everybody calls. let's say I wanted to do this more intelligently and not just assume that we have a 255.255.255.0 subnet mask, but that we're actually going to honor real subnet masks. Or maybe, and I'm trying to think, yes, when I talked in the previous lesson on data normalization, remember I used that package from that was called IP address. I always want to call it net address because that was what it was called before it got subsumed by Python. But we use this thing, IPv4 address. There are IPv4 network. Maybe I want to change to make this a little bit more realistic. Now what would happen if I did that? If I changed it in create devices, and then at a later point in time, if I wanted to get a tuple, guess what? This code will still be the old code. Or I would have to change it twice. This is why we say copy and paste is not a good idea. If I want to make a change here, no matter how small, maybe I want to restrict this to being 200 or something, I would have to go down and make that change down here as well. Just a bad idea. So I put on my thinking hat and I say, let's think about this a little bit more. Maybe what I don't want to do is recreate all this code. Instead, what I'm going to do is delete all of this code. And now what I'm going to do is I'm going to actually call this function. So what I'm going to do is I'm going to say, I'm going to return created devices. Actually, so let me, because this is possibly going to be confusing, what I'm going to do is I'm going to get rid of that, and what I'm going to say is in my my create devices tuple, I'm actually going to call create devices. Do you see that up there? And what am I going to pass in? All I need to do is say num devices and num subnet. Num devices equals num devices, num subnets equals, let me get rid of this so I can read it, num, and you can see it's right there. Now, let's review, let's refresh our memory. What is this thing right here? This is a keyword. What is this thing right here? This is the attribute or parameter that I want to pass into that function, okay? And for those of you that care about calling it one or the other, my apologies, just trying to be maybe simpler here. However you want to think about it, but this is the keyword so that when I call create devices, let me do a control B here. Control B will take me to the definition of this function. Whoa, it took me to the thing that I just was at a minute ago. In fact, see, you can see both of these right here. Now, what's the advantage of doing this? Well, if I make changes to what I do here, maybe I use the IP address package from Python, and in order to create my subnets and my devices, maybe I have a new way of creating my device, maybe I pass in new things, etc. It doesn't matter because my create devices tuple is going to return this, and it's going to return it as a tuple. And if I've done this correctly, it should run. Let's give it a shot. Well, surprise of surprises, it actually ran, and it's returning a tuple. So you can see that, and if you don't believe that that actually did that, yeah, I'm actually, well, yeah, let's make sure, so that you are convinced that this actually worked. And sometimes I need to do this myself. I'm going to delete all the tupeliness of this and just return create devices, and I'm going to run this, and what I get is a list of devices. And if I undo what I just did and return it to returning a tuple, and I run it, assuming that I did that correctly, it's returning a tuple. So look, I preserved and I'm reusing all of the data that I do in create devices. You definitely 100% want to remember to do this as much as possible when you become a software developer. Okay, so we've looked at the badness of copy and paste and the goodness of reusing things that you've already written and writing your functions in such a way that they can use that. Now, the last thing that I'll show you is this. What I probably would do is I would just say, you know what? I'm going to get rid of this entirely. And the simplest thing to do, because I created a bunch of code that I then have to support, what I'm going to do instead is, if I really care about having a tuple, all I'm going to have to do is this. Put my tuple here and basically create devices. I'm going to get rid of that because that doesn't exist anymore, remember? And I'm going to change this to be back to create devices. Now I'm calling my one function that returns a list of devices via create devices. I'm going to call that, and right here where I need a tuple, I'm going to actually convert it into a tuple. And let's see if I've done this correctly. Another surprise, yep, it worked, so that's good. By the way, if you're like me and you notice, wait a minute, I saw some of that data change. Think about it for a second. Why is this data changing when I run it? I'm going to run it again. Bloop. See that? It changed. Run it again. Bloop. See, it just went from Juniper. The next time was Cisco. The next time was Arista. Take a look at this again. You're going to see it change again because I am generating random devices. Remember, that's what create devices calls create device, and it's just generating random stuff. In your real world situation, you won't be creating random stuff, so your situation will be to return the same data, which will be correct data every time. But for me, and for the way that we're doing things, it's random data. Okay, this seems to be a very easy way to do it. I've not had to modify this function here, create utils. Let's see if I actually, where is create utils? It's in basics, isn't it? Yeah. Well, it shows that I've made a change, and I'm not sure what the change actually is. But you notice before I added underscore tuple, and I did a big copy and paste, and then I did a little function that called this one. Now I'm not really changing anything in here. It's exactly the same as it was before. The only difference is in my function where I needed a tuple. Then I did this, and sure enough, it worked, and it's the smallest amount of code. All I really had to do this whole time that I showed you that stuff that I've spent, let's see, I'm looking at my timer as I'm recording this, 18 minutes and 20 seconds. I could have just typed in tuple like this, and we would have been good to go. But I did want to go through that less optimal way of doing it, and hopefully you get an idea. And this is actually, I just want to reiterate this. This is what will happen to you when you're writing code quite often. You'll start with the simplest way of doing something, and you'll get it to work, and then you'll say, oh, I can make that better. So I'm in here, remember, first I copied the whole thing, then I said, oh, that's not a good idea. I can make it better by having a function called create devices tuple and just coerce the list into a tuple and return that. And then I said, well, wait a minute, why am I even creating a new function to do that? Why don't I just do it right here? And so this, in my situation anyway, is the easiest way to do that. All right, so now that we know what tuples are, we've seen them in action and written some code that actually uses our devices and creates a tuple out of a list, etc. You may be asking the question, well, what is a tuple good for? I know that it's immutable and it can't be changed, but what value is it to me? Well, like in many things in life, the way to get an answer to something like this is you ask the great Google in the sky. And so I've done that just to give you an example of how you might find stuff. And then you go through the answers and you find ones that you like. So I went through a few of these, and I found one that I actually think is concise and quick and decent. So what I'm going to do is I'm going to show you. I ended up going down to here, list versus tuple, when to use each. I've looked at some of the answers and read them. I've noticed that what you see here, by the way, Stack Overflow, very useful source of good information. But unfortunately, just like in life, you'll end up with a lot of people that basically say, you moron, you shouldn't be doing this, blah, 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 and then other people piling on, etc., etc. So you have to kind of ignore that or just pay as much attention to it if you want. Here I found one that actually got a lot of upvotes, and so it seems to be decent, and it even gives where they got this information from. So there's probably something that you could even further explore. And then again, down here, there will be people that say, oh, well, there is something problem with that answer, and or in this situation, this person is being at least kind of gentle and saying the analogy only goes so far, which is true. Anyway, let's just review. This is saying some things about a tuple. You can't add elements to a tuple. You can't do append or extend. I didn't go into this, but probably good that you should know. I suspect you assumed it, but you can't remove elements. So remove or pop are things that you can do in a list, but you can't do those with a tuple. Here, we haven't even actually done this, but with lists, you can actually tell Python to find things, and that is true equally with a tuple. We'll talk a little bit about how stuff is stored in just the general data representation of a tuple, the way that works. And also you can use in, which is basically doing the same thing to find things. So that kind of gives you a little bit of information about the tuple. Here's the reason why you might want to use a tuple. Tuples are faster than lists. For me, if you're writing Python code, you don't care a whole lot about performance. And if you're like network management, network monitoring, etc., high amounts of performance are not really something that is keeping you awake at night. If you're writing embedded code, you're probably using a language like C or Go or something like that anyway, so you wouldn't be using Python. But it is true that tuples are faster than lists. I actually looked this up using the great Google in the sky, and it sent me to a list where somebody actually did some measurements, and I was surprised at how much faster it is. So if you're not ever going to change it, then you might consider using a tuple instead. Again, converting a list to a tuple is a one-time cost, and then all of your iterations are that much faster. This is something that some people complained about. In computer science-y type stuff, you have things that are read-only. Database stuff can be that way. There's other things that need to be read-only. If you give somebody a tuple, then they shouldn't change it. Well, they can't change it. Now, nothing will keep them from creating a brand new tuple or changing it to a list or whatever, but that is true. Now, here's something I want to spend a little bit of time on, and I'm going to tell you a word that is really important, and I don't think that they use this word here. And I want you to remember this. And I want myself to remember to put a little call out on the video with this word. But if I don't do that, my apologies. The word that I want to talk about is the word hashable. And here, let me back up a little bit. When we do something like a dictionary, remember a dictionary has what? It has something value pairs. A dictionary has key value pairs. What is that key? Well, you don't know this yet, or maybe you do know it. I can't remember how much I might have gone into it. But the key for a dictionary must be immutable. In other words, it can't be a data type that ever changes. So what have we used for keys for dictionaries? Usually, in our examples, we've used strings. And as you know, strings are immutable. They cannot be changed. And therefore, and here we get back to this word hashable, therefore, they can be hashed in order to create instant access to items in something like a dictionary that has keys. The way that a dictionary works in other languages, we call this a hash table or a hash map. And basically what the computer language will do, whether it is Python or Ruby or C or Java or JavaScript, when you have something, a data type like this with the key, it will take the key and it will do a mathematical type function on it called a hash, and that will be a pointer into the actual memory on the computer where that item can be found. So all you need to remember is that the key is the magic thing that helps you to find it, and the key needs to be immutable so that it can be hashed. And the word that we use for that is hashable. So a key, a list, cannot be a key for a dictionary. Why? Because lists are mutable. They can change. A dictionary cannot be a key for your dictionary because, again, your dictionary can be changed. But think about this. What about tuples? What did we say about tuples? Tuples are immutable. That means they can never change. And I'm not going to go into great details of this. The writer does mention that the items in the tuple has to be immutable values like strings, numbers, or other tuples. So in theory, you could have a tuple that has as one of the items a dictionary. That wouldn't work. But if your items in the tuple, like in our situation, are actually, in our original situation where I was using numbers, those can be used as keys in a dictionary. And we're going to talk about sets in the next lesson, but you'll learn about hashable in that regard as well. So, important word, hashable. You can look it up, again, using the great Google in the sky to understand what that actually means in Python. Hopefully I've given you a little bit of information, but this is true. Some tuples, that would be tuples that actually the items are all immutable, can be used as dictionary keys. Would you want to use that? I don't know. I've never used a tuple as a dictionary key. My coding has been simple enough that I don't need to worry about that. Going back to what we did with our PyCharm, remember? So think about this. This is what? It is a tuple, right? What are the items in a tuple? The items in the tuple are dictionary items. Therefore, can this tuple be used as a key for a dictionary? And the answer is no. And why is that? Because of the fact that the items that are stored in the tuple are themselves mutable. So if this was like a number, 1, 2, 3, 4, for all of these things, and a number only, then it would be able to be used as a key to a dictionary because it would be hashable. Let me see if I still have this up to give an example. So in my example here, where's my tuple? This tuple, could this tuple be used as a key in a dictionary? Now the key would be this entire tuple, 1, 2, 3, 9, string. Oh, wait a minute, that string. Oh, wait, you remember, strings are what? They are immutable. They cannot be changed. So in fact, I believe, although I haven't tried it, this tuple should be usable as a key in a dictionary. So hopefully that gives you a general idea about tuples. We've seen a little bit about how they work. We've seen a little bit about what they are. And hopefully it's rounding out your education and knowledge of the Python programming language. Enjoy tuples. Okay, so this lesson on tuples is done. Let's quickly review what we talked about. We talked about what a tuple was. We compared it to a list, established that it is indeed immutable. You can't change it. You can't do things like append to a tuple. You can to a list. That's the example with a list. That's the example with a tuple. Then we looked at some code. We looked at create devices. We showed some stupid ways to do creating devices as a tuple, and then we showed a simpler, better way. Hopefully you learned something about writing better code. Then we briefly looked into, okay, well, why might you want to use a tuple rather than a list? And so we talked a little bit about them being faster than lists, about them being immutable, and also that they can be used as dictionary keys. And we talked about the idea of hashability, if something is hashable or not. So hopefully this was a good lesson to help you understand tuples. At least you'll probably encounter them in the wild out there, either code that you write or somebody else has written. Hopefully this gives you an understanding so that you will know how to deal with it and when to use them and when to not to. Thank you.